Hi everyone, welcome back to our channel. In the last video we have discussed on the section sets and their representations and the example problems related to it. If you have not watched it yet, please do watch and do comment if you have any doubts. In this video we will be discussing on the exercise problems, exercise 1.1. So without any delay, let's get into the video. Exercise 1.1, question number 1. Which of the following are sets? Justify your answer. So the first question is collection of all months of a year beginning with the letter J, June, July. So it's a well-defined set. Means, what is set? Set means it's a well-defined collection of objects, right? So it's well-defined, right? We have no arguments on that. We know there are only 2 months with starting with the letter J, that is June and July. So this is, yes, it's a set. What about the collection of 10 most talented writers of India? Can we have a well-defined collection for that? Because for person to person it may vary, right? What I think may not be what you think. Like in my mind, the most talented writers of India will be different, and in your mind it will be different. So it is not a well-defined collection of sets. So the option is no. A team of 11 best cricket batsmen of the world. This one is also the similar one, right? See, the 11 best cricket batsmen of the world. For me, the best cricket batsman will be different from what yours is. So it depends upon the person's interest, person's likes or perspective. So this one is also no. Collection of all boys in your class. That is a well-defined collection, right? You know how many boys are there in your class and what all are their names. So it's a well-defined collection. So we can say it is yes. The collection of all natural numbers less than 100. That is also well-defined. For all of us, it will be the same answer, right? So this is also yes. The collection of novels written by the writer Munshi Premchand. Even that is a well-defined collection of sets, right? The writer is already mentioned, so we can write the collection of all the novels that has been written by this particular writer. So it's a well-defined collection of objects. So the answer is yes. The collection of all even integers. That is also a well-defined collection. So we can see it as yes. What about 8th one? The collection of questions in this chapter. Even that is well-defined collection, right? We all know, like if we are studying this chapter, we know the collection of all the questions. It doesn't vary from person to person. So this one is also a yes. Collection of most dangerous animals of the world. The most dangerous, that perspective will be different for different people. Like what I find the most dangerous animals may not be your answer. What you have in your mind will be different. So we can't define it as a well-defined collection of objects. So we can write it as no. So the first option is yes. Second is no. Third is also no. Fourth one is yes. Fifth is also yes. Sixth is also yes. 7 is also yes. 8 is also yes. And 9 is no. Question number 2. Let A is equal to 1, 2, set of 1, 2, 3, 4, 5, 6. Insert the appropriate symbol. This symbol means belongs to, and this symbol means does not belong to. So we have to check whether the given option, from the given option, whether the given options belong to the set or not. So the first option is whether 5 belongs to or does not belong to the set A. We can see from the set A that 5 is an element of the set. So we can write 5 belongs to set A. Let us look at the option 2, 8. The set is 1, 2, 3, 4, 5, 6. 8 does not belong to the set A, or 8 is not an element of set A. So we can write 8 does not belong to set A. Let's look at the third option. 0. 0 is not an element of set A, so we can write 0 does not belong to set A. Fourth option, 4 is an element or not. Yes, 4 is an element of set A, and we can write 4 belongs to set A. Option number 5, 2 Yes, 2 is an element of set A, so 2 belongs to set A. The sixth one is 10. Does 10 is 10 an element of set A? No, 10 is not an element, so 10 does not belong to set A. Question number 3. Write the following sets in roster form. Roster form means all the elements of the set are listed and the elements are separated by commas and they are enclosed within braces. So let's look at the first option. The set A, it is given for all x such that x is an integer and x value lies between -3 and 7. So integer means it can be negative integer, negative numbers, 0 and positive numbers. So x should be anyway greater than -3. That means -2, -1, 0, 1, 2, 3, 4, 5 and 6, since x should be less than 7. Let's look at the second option. The set B, such that for all x such that x is a natural number and it should be less than 6. So natural numbers always starts with 1, right, and it should be less than 6. So from 1 to 5, 1, 2, 3, 4 and 5. Now let's take a look at the third option. Set C, it is given x is a 2-digit natural number such that the sum of its digits is 8. So let's write the 2-digit numbers such that their sum should be, the sum of the digits should be 8, right? So 17, 1 plus 7 gives us 8, 26, 2 plus 6 gives us 8, 35, 3 plus 5 gives us 8, then 44 gives us 8, 53, then 62, then 71 and 80. So all these are 2-digit natural numbers, since natural number starts from 1 till infinity. So all these belongs to the natural numbers and all these are 2 digits, and if we add all this, if we add these 2 digits we get 8. Even if we add these 2 digits we get the sum as 8. 8, 8, 5 plus 3 is 8, 6 plus 2 is 8, 7 plus 1 is 8, 8 plus 0 is also 8. Now let's take a look at the fourth option. Set D, for all x such that x is a prime number and which is a divisor of 60. So that means we have to prime factorize 60. So the least prime number that can divide 60 is 2, giving 30. Again 2 is the smallest prime number that can divide 30, giving 15. Next smallest prime number that can divide 15 is 3, giving 5. Now 5 itself is a prime number, so 5 is divisible by itself, giving 1. In roster form, the main property is that the order in which the elements are placed is immaterial, but the elements should not repeat. So here there are 2 times, 2 is coming 2 times, right? So we have to write only it as 1 time, 2, 3, 5 is the answer. Now let's take a look at the next option, 5. The set E is the set of all letters in the word trigonometry. So as I already mentioned, in roster form, the elements should not be repeated. So, and the order in which the elements are written does not matter. So we can write T, R, I, G, O, N. Again O is already there, we don't need to write O again. M is okay, E, okay, T is already there, R is already there, and again Y. So we can write it as this roster form as T, R, I, G, O, N, M, E, Y. Now let's take a look at the sixth option. Set F, the set of all letters in the word better. So B comes E, then T, again T, so it's already written, so we are not taking T again. E already written, so we are not taking E again, comma R. Now question number 4, write the following sets in the set builder form. So in set builder form, all the elements in this set possess a single common property and which is not possessed by any element that is outside the set. So all the elements inside the set will be having a common property, and any element that is outside the set does not have this property. So let's write these sets in the set builder form. So the first question is 3, 6, 9, 12. From this we can understand that the property that these elements possess is the multiple of 3, right? 3 into 1 gives us 3, 3 into 2 is 6, 3 times 3 gives 9, 3 times 4 gives us 12. So the multiple values are from 1 till 4, right? So we can write this set as, let the set be A is equal to the set of all x such that x is equal to 3n, that means multiples of 3, where the value of n lies between 1 and 4, right? 3 into 1. So if n is equal to, say if n is equal to 1, we write 3 into 3 times 1, which gives 3. If n is equal to 2, we write 3 times 2, which is equal to 6. If n is equal to 3, we get 3 times 3, which is equal to 9. And if n is equal to 4, we get 3 times 4 is equal to 12. So which matches with the elements of the set. So we can write it in the set builder form as x for all x such that x is equal to 3 times n, where n's value lies between 1 and 4, including both 1 and 4. Now let's take a look at the second option. 2, 4, 8, 16 and 32. So from this set we know that all these elements of the set possess a property where 2 raised to the power 1 gives us 2, 2 raised to the power 2 gives us 4, 2 raised to the power 3 gives us 8, 2 raised to the power 4 gives us 16 and 2 raised to the power 5 gives us 32. So we can write the set in the set builder form as for all x such that x is equal to 2 to the power n, where the value of n lies between what? 1 to 5, right? Lies between 1 to 5, including both 1 and 5. So let me represent this set as A. So the set of all x such that, these two dots mean such that, and this braces are used to represent the set of all. So the set of all x such that x is equal to 2 raised to n, where the value of n includes both 1 and 5 and also the values between 1 to 5. Now let's look at the third option, that is 5, 25, 125 and 625. So 5 to the power 1 gives us 5. These elements possess the property that 5 to the power 1 gives us 5. 5 to the power gives us 2 gives us 5 times 5, which is equal to 25. And 5 to the power 3 is 5 times 5 times 5, which is equal to 125. And 5 to the power 4 gives us 5 times 5 times 5 times 5, which is equal to 625. So we can write the set as the set of all x such that x is equal to 5 raised to n, and the n's value is between 1 and 4, including both 1 and 4. Okay, so we can write it as for all x such that x is equal to 5 raised to n, where the value of n is greater than or equal to 1 and less than or equal to 4. Question number 4, 2, 4, 6, etc. So from this set we know that all the elements of the set possess the property that these all are the even natural numbers, right? So we can write it in the set builder form as set of all x such that x is an even natural number. This is 2, 4, 6, 8, 10, etc., etc., right? Now let's take a look at the fifth option. 1, 4, 9, etc. till 100. So here we can say these elements possess the property that if we square the natural numbers, we get these values, right? See, 1 square, we get 1. 1 is the natural number. When 1 square, 1 raised to the power 2 gives us 1. Now let's take the next natural number, that is 2. 2 raised to the power 2 gives us 4. Now let's take the next natural number, that is 3. 3 raised to the power 2 gives us 3. Now let's take 100 will be 10 raised to the power 2, right? It gives us 100. So we can write this as the set x, the set of all x such that x is equal to n raised to the power 2, where n belongs to the set of natural numbers and value of n lies between 1 and what? Value of n lies between 1 and 10, right? N should be greater than or equal to 1 or should be less than or equal to 10. So we can express it in the set builder form as this. Now let's look at the next question. Question number 5. List all the elements of the following sets. So let me take the first option. Set A such that for all x such that x is an odd natural number. So odd, and it should be natural number. Natural number starts with 1. 1 itself is an odd number. So 1, 3, 5, 7, 9, etc. Now let's take a look at the second question. B. Set B. For all x such that x is an integer and x value lies between negative 1 by 2 and 9 by 2. So negative 1 by 2 is equal to negative 0.5 and 9 by 2 is equal to 4.5. So x value lies between negative 0.5 and 4 by 5. Since x is, it's already given x is an integer. Integer means it should have values like positive, negative and 0. It can neither be fractions nor decimals. So the values that can be listed are it should be greater than negative 0.5, right? So it can be 0, 1, 2, 3 and 4, since 4 is less than 4.5. Okay, now let's take a look at the third question. The set C. It is given x is an integer and x square should be less than or equal to 4, which means any value that we take for x, that is, it should be an integer, and if we square it, it should have the value less than or equal to 4. So let me take x as negative 3. If we take x as negative 3, then x square means negative 3 the whole square, which gives us negative 3 into negative 3. So 3 3s are 9, and negative into negative, it becomes positive. So it is greater than 4, right? So this is not the value. X is equal to negative 2, then x square is equal to negative 2 the whole square, which gives us negative 2 into negative 2, which is equal to positive 4. That is okay. So we can take x is equal to negative 2. Now say x is equal to negative 1. So x square means negative 1 the whole square, which means negative 1 into negative 1, which is equal to positive 1. Then if x is equal to 0, then 0 square is 0. X is equal to 1, then 1 square is also 1. X is equal to 2, then 2 square is also 4. And if x is equal to 3, then 3 square is 9, which is greater than 4. So we can write the elements of the set C as negative 2, negative 1, 0, 1, 2. Now let's look at the fourth option. D. Set D. The set of all x such that x is the letter of the word loyal. So let me write the elements listed. L, O, Y, A, again L, right? L is already there, so we don't need to repeat it. Okay. Now next, fifth option is E, set E, the set of all x such that x is a month of a year not having 31 days. So let's write all the months that are not having 31 days. That is February, April, June, September and November. Now sixth option, set F, the set of all x such that x is a consonant in English alphabet which precedes k. Consonant means it is not a vowel, and it is already mentioned it should precedes k. That means it should not exceed after k. It is after A, B, C, D, E, F, G, H, I, J, K, till k, not beyond k. So let's take all the letters of the English alphabet till k without including k, and it should be not a vowel. So A is not A, B, C, D, E, F, G, H, I, J. K is not needed since it is given which precedes k. Okay, so k is not needed. Now A is a vowel, so not needed. E is a vowel, not needed. I is a vowel, so not needed. So we can write B, C, D, F, G, H, J are the elements of the set F. Now let's look into the next question. Next question, match each of the set on the left in the roster form with the same set on the right described in set builder form. So let's solve the set builder form. X is a prime number and is a divisor of 6. So let's do the prime factorization of 6. So the least prime number that can divide 6 is 2, giving 3. 3 itself is a prime number, so 3 is divisible by itself. So the prime x should be a prime number and is a divisor of 6 is 2, 3. So this matches with the second option. Option B, x is an odd natural number less than 10. It should be an odd natural number and should be less than 10. So 1, 3, 5, 7, 9. So this matches with the fourth option. Now let's see C option. X is a natural number and is a divisor of 6. X is a natural number and is a divisor of 6. So we can say 1, 2, 3, 6. Since 1 into 6 gives us 6, 2 into 3 gives us 6, 3 into 2 gives us 6, and 6 times 1 gives us 6. So we can write 1, 2, 3 and 6 as the it should be natural numbers and is a divisor of 6. It has not given like it should be prime number. So we can write 1, the condition is that it should be a natural number and should be a divisor of 6. So we can write 1, 2, 3 and 6. Now let's take this matches with the option 1. Now let's look at the option D. X is a letter of the word mathematics. So M, A, T, H, E. Again M is already there, so we don't need to repeat M again. A is already there, no need to repeat M again. A again. T is already there. Now I, C, S. So this matches with the third option. So we can write A matches with second option, B matches with fourth option, C matches with the first option, and D matches with the third option. That's all for today's video. I hope you understood the concepts. If you have any doubts, please do comment your doubts on the comment section. Thank you.